Hi, in this session we're going to talk about acceptance testing. We're going to have a small intro to the language Gherkin that can enable you to communicate clearer with your non-technical business people. We're going to look into what Specflow is, and obviously we have to make a small demo as well. So this is the agenda for this small session. I'm going to make a small intro to what acceptance testing is and how that fits into the testing pyramid. I'm going to give you a small and short introduction to the Gherkin language and how that can be used to actually communicate clearer with your non-technical business people. We're going to look at what Specflow is and how that can interact with Gherkin to actually make your code run automated acceptance testing. And as I said, we're going to end the session with a small demo so you can see how it all works together. The session goals are to get a clearer understanding of the role of acceptance testing, when should you do it and why should you spend time on it. How can Gherkin help you communicate business requirements clearer in the organization, the role of Specflow together with Gherkin, and as I said, a small demo on showcasing how it all works. You probably know this one. This is the test pyramid. As you all know, tests are one of the fundamental pillars of CI/CD. We have to make sure that when we implement new features or change existing features, that it's covered by tests so that we don't break anything and the system actually performs the way that we expect it to. But each type of test validates different things in the application. Unit tests is obviously the most important, but also integration testing and end-to-end tests are very, very important in their own manner. Tests are good. I think there's no question mark about that. But as you all know, there's no free lunch. Everything comes at a cost. So if we start to take a look at unit testing, that's the pillar of everything. That's the bottom of the pyramid. They're very cheap and they're very fast to implement and they're very fast to run as well. They test functionality in a single class in isolation, so we actually mock or stop all the dependencies of the class, so that we know that it's only that one single class that we're testing. The number of unit tests are usually very, very high. We have a lot of tests covering different scenarios of each of our components. So this is the foundation of our test suite. The middle layers in the integration test, which more expensive to implement and they run a bit slower than unit tests usually. And what integration tests do, they take a set of components and test that they actually work together as expected. You can still mock or stop some of the dependencies if you want to, but essentially they test that everything is working together as expected. The number of integration tests are usually lower than the unit tests because they're more expensive to implement and they run slower. So that's like a rule of thumb. It's not always true, but that's the rule of thumb. And then the top of the pyramid, that's the end-to-end testing. And this is the layer where acceptance testing is also a part of. It's more expensive to implement and they run slower than unit tests, but it's still can be used as a cornerstone of the BDD way of delivering features to your business. So the acceptance test and the end-to-end test in general, they exercise the application as a whole. So they spin up the application and they sort of push one button. We expect something to happen on the screen, or we make a request to the API and we expect a certain behavior. So it's kind of like a black box testing. We will still usually mock or stop the external dependencies, but all internal dependencies like databases and stuff like that are tested as a part of the test. So they're usually containerized because that's an easy way to do it. But all the internal dependencies should be spun up as a part of the end-to-end or the acceptance tests. And just like before, we have fewer acceptance tests than we have integration tests, and that's because they're quite expensive to implement. So that's a very important part. I'm sure all developers know this guy in the corner. This is like the product manager or the product owner or some non-technical person in your organization that has a lot of great ideas and a lot of thoughts about what the system could do. It can be very hard to communicate with these people and actually kind of getting them to agree on what they expect the system to do in different scenarios. And this is where Gherkin comes in. Gherkin is a language that can actually translate business requirements into test scenarios. And it's written in plain English. So if you actually want, you could teach your non-technical business people to write Gherkin in a certain manner so that they could actually provide you in plain English what they expect the system to do under different scenarios. So it will definitely make it easier for developers to communicate with testers and business stakeholders. And it's very, very easy to integrate with existing testing framework for automated testing. That could be XUnit or NUnit, whatever testing framework you actually use. This means that you can write tests that can be automatically spun up and executed as a part of your build pipeline so that you ensure that everything is working as expected before you actually put it into production. As I've already mentioned, Gherkin is written in plain English. There's a few constraints that they have to follow in order to actually make sense. And it's following the given, when, then syntax. So if we take a look at the unit testing world, we have arrange, act, and assert, and it's kind of like the same. But basically, Gherkin documents are plain text files, so it can be opened in Notepad if you want to, and it could be written in an email even. So if you could persuade your business people, your stakeholders to write in the Gherkin syntax, they could actually provide you with what they expect a certain feature to do when it's under different circumstances in the application. So Gherkin describes software features and the expected outcome under different conditions. So in this scenario I've written here is a small test of maybe an API in a bank. So given I have an account with a balance of $100, when I deposit $50, then my account balance should be $150. That makes sense. The stakeholders can understand it, the developers can understand it, and the developers can actually take this Gherkin and use it for writing tests, and that's what I'm going to show you a little bit later. But first, let's dive into the three different steps. So the given sets up the initial context of the system or state of the world if you want. So it could be like the given that the user is logged into the account. If we have an API or maybe a website that you have to be logged in to actually exercise of different parts of the system, this could be one of the initial context that we have to set up first. It could also be given some request to an external API is successful or something goes right or wrong as a part of one of the external calls. But it could also be that we're not logged in. So given the request to the API is unauthorized, so we don't have the authorization to actually call the API, that could also be an initial context of the system. So this given actually, I'd say, is exactly the same as the arrange part of a unit test. Moving on to the when. The when is the actual action that the user or some system performs on your application. It is what is happening. We are doing something to the application that we expect something to happen afterwards. So when the user clicks on the deposit button, when the user clicks the button initiating the external API request, when the API is called with a valid request, when the API is called with an invalid request, and so on and so forth. It actually triggers the behavior that we want to test. So this actually is the same as the act in our unit tests. And then we move on to the last part. That's the then. And that's where we actually test that the application has performed in a way that we expect it to. So this is the same as the assert part of our unit tests. Then the account balance should be updated. Then the screen shows the data retrieved from the external API. Then the API responds with the HTTP 504.403 or whatever you expect the system to do under the initial context that you set up and the action that you performed on the application. Obviously, it can be a lot of different parts of the system that should be set up, and that could be different stuff. Different when steps that we have to do to go to a certain corner of the application, and there could be multiple steps that we want to test afterwards under the then. and we can chain together the different steps with the and keyword. So again, this will just be plain English that will have a few steps that are linked together with the and statement. The example here is given I have logged into my account and my account has saved a shipping address when I add a book to my shopping cart and I proceed to checkout, and so on and so forth. The and word can be used to chain together different steps. So Gherkin enables us to write in plain English how we want our application to perform under different circumstances. The next step is taking the Gherkin and translating it to .NET so that we can exercise our code. And this is where Specflow comes in. Specflow maps Gherkin to methods in .NET, so each step will be mapped to a method that will perform the setup or the action or the validation of the what is going on. It generates codes and hooks that facilitate the automated testing, and it also has hooks for setup and teardown for each test session, so that we could set up a container and tear it down when we're done doing different things. And that's basically leveraging Gherkin to actually do .NET code. But I think that's enough PowerPoint talk. Let's look at a demo. I've made a small application which is a dad joke API. It does not have a UI. I want to keep this as simple as possible. However, it's important to note here that if you have an UI, you can use a tool like Selenium to actually test through the through the UI if you want to. But we don't have a UI here. I want to keep it as simple as possible. So it's only an API. The API can do three things at the moment. It can return a random joke, it can return a specific joke, and we can create a new joke. But let's jump into Writer and take a look at this small application. We have a web API here. It has one controller. Nothing fancy. We have three methods, as I already told you. We have a get method that would return a random joke. We have a specific get for a joke with a certain ID. And we have a post endpoint for creating a new post. I've created a create dad joke request, which looks like this. It's just a record which has a opening and a punchline. And it will return a joke which has an opening and a punchline just like before. And it also has an ID that we can return to the caller so that they know which ID the joke has been given. If you look at the domain, we have a few interfaces. We have a dad joke service, that implements these three methods that we have to use, and we have a repository that can facilitate the saving, basically, of the jokes. Now, I haven't really made a complex solution. I have made an in-memory dad joke repository where we just have a list of jokes. So as soon as we shut down the application, all jokes are gone. But in order to keep this as simple as possible, I don't have any database or anything like that. The dad joke service basically is just a pass-through at the moment. We could have some data here that some business logic here that could do different stuff, but right now it's just a pass-through as it is right now. So let's just try and run it and see what we can do. I've prepared a few requests here. Let's just spin it up. So let's see. We can create a new joke. So I got fired from the transmission factory today. Apparently, I was not putting in enough shifts. Get that return, and it has ID of 1. So if we call the get request with 1, we get the joke back, and we get a random joke here. Obviously, there's only one joke at the moment, so we will always get this one back. So very, very simple stuff here, but it will do enough for us to actually show what Specflow and Gherkin can do for us. Just close all this, and then let's take a look at the acceptance test project. We have 3 folders. So we have features, hooks, and steps, and let's just go through them one by one. If we open the features first, this is where we have our Gherkin. This is basically just a description of what we want this file to contain. This is a simple test of the dad joke API. So this is just a way to communicate in our test explorer what feature we actually have here. And then we have the scenarios, and the scenarios are basically a test. And we have this is the title, which is here, get a random joke. And as we can see here, we have the given, when, and then. I have installed a small Specflow helper here in Writer. I think there's one for Visual Studio as well. So that actually makes it a little bit easier to navigate from the feature file to some of the other files. The steps are the C# code that are linked together with our Gherkin. So if I just open the joke step definitions, let's just do like this so that we can see both of them. Oh, here we are. So the Specflow files have to have the binding data annotation in order for Specflow to actually kind of make the link and pick up where Specflow should connect to the features. And as you can see, we have a given attribute on one of our methods where the regex is a joke already exists, and this is the same text as we have here. So let's say I don't have this file, this method. We can see that Writer says, hey, you don't have this method. So if I do this, create step, I do it in this one, then it will actually make a small template here for our method. Let's just skip this. Yeah, thank you. And let's go back. So our given here is that a joke should already exist. So what I do here is I create a small joke object. I call create joke, which is right here. And that actually just calls our API right here. So we post it to the API, get the response message back. I deserialize it to a joke, and I return the joke here. And then I save it in the scenario context. And the scenario context is quite important. This is what we use to carry important values between the different steps. So it's just a key value dictionary. So I add the created joke with the key created joke, and then I can pull it out in one of the other steps when I need to look at that. Well, let's look at the when step. The endpoint for a random joke is called. Now I just call the endpoint, and I expect to get a joke back. And I also save that at the scenario context so that I can actually check that it's the correct joke that I got back. And then in the then, I validate that when I pull out the joke from our scenario context that we added here, it should not be null. And that's basically the test. So I create a joke just to make sure that the state of the system is correct. We already know this existing joke now. I call the random joke endpoint and save that in our scenario context, and I validate that the joke has actually been created. As you might have noticed, I inject two things into my joke step definitions class. I inject the scenario context, and I inject the an HTTP client. So where does they come from? And this is where the hooks come in. Now, if we open this one, let's put it away here. So the hooks are different steps in the lifetime of the test session, and this is where we set up different things. Let's just take a look at. Oh yeah, we have the containers. Oh, sorry, we have the object container, which is injected by Specflow. And the object container is basically the DI container for Specflow. So all the stuff that we need in our tests, all the different stuff that we inject here, should already be added in the object container. So I create a HTTP client, and I inject that into the object container. But let's just dive into how we actually spin up our application. I've made a small class called Web Application to Test, and that is just a class that inherits from our Web Application Factory. Web Application Factory is a way to spin up your application in memory so that we don't need a server. We can just spin it up. And we can override the configure web host method on the Web Application Factory in order for us to set up different things. I'll get back to this a little bit later. But one small catch is that we need to specify the class that the factory has to spin up, and the program class actually points to the program in Web API. But in order for Web Application Factory to use it, we need to make a small workaround here, because the program class here is actually internal, so that can't be seen in the other project. But if we do this small trick, public partial class program, then we can use it here. So just a small gotcha there. So let's close this. As you can see, there's a few different annotations on the different methods. So obviously, before test run is before the test session is started, and before scenario is before each test. So before each test, we spin up a new application. That means we clear everything and make sure that the tests are clean, has a clean slate to run from. But let's write some code. Let's say that our stakeholder comes up with a new idea. We want to make sure that we don't have duplicates jokes in our database. We just create a joke just for something to so that we know that one joke is actually present in our database or in our repository. And then we want to add the same joke again. And then we want to make sure that the joke should not be added. We don't want a new ID coming back. So as you can see, I leverage the same method for creating the joke, but the two other steps are not defined yet. So let's create those. So when I add the same joke again, and if we look at the given joke already exists methods, you can see that I save the created joke in the scenario context. So now I can pull that out and actually try to do the same, create the same joke again. Sorry, I just realized that this is the joke that we get back. Obviously, let's just save the create that joke request in the scenario context as well. Joke to create and add joke. Now we can get the same object out of the scenario context and try to create it again. So that's the when step that we're trying to do. So joke to, and I pull it out. Create joke, joke to create. Let's just await that and make that async. Let's just introduce a variable joke2. Let's call it that, and we'll add it to this to the scenario context so that we can use joke2 to check that it's actually the same as the first joke that we created. All right, and then to the next, the then step. Let's create a method for that. Now we basically just want to ensure that the ID of joke2 that we have in the scenario context and the original joke that we created in our given step are the same. So I pull out joke1 from the scenario context. And it's a joke. And what was it created joke? Let's just check, is it the correct created joke? Yes, it is. All right. and joke 2, scenario context get, joke, and joke 2, yeah, like that. And we do this. All right. I'm going to build the solution, and it will show up in the Test Explorer. Here we are. Let's run it. Oh, I just realized, yeah, it passes, and it shouldn't pass, right? And that's because it should be the same. Let's try again. All right, that's better. Okay, so let's implement the solution to this. Let's make a quick and dirty solution. Let's go here, create joke. Let's just test if the joke already exists. So jokes the same. No, let's pull it out instead. Let's do joke single or default, and then we want the same here. Let's do this. Okay. And if the joke is not null, we already have the joke in the repo. We just return the joke from the repo instead of actually creating it again. All right, let's run it. Oh, I have a syntax error somewhere. Oh, I totally get that. Let's try again. We run the code and hopefully it will pass. So now we know that if we try to add the same joke that is already existing in the repository, the existing joke will be returned instead of creating a new one. So that was a very, very basic example of implementing in an acceptance test that shows that if we try to make a duplicate in our repo, we will return idemponently instead and return the joke that already exists. Very, very simple stuff. Obviously, this is an in-memory repository. This is not a very realistic scenario. Usually you would have some sort of database, and that actually bridges well into the next thing that I want to talk about. And that is the different dependencies, the internal dependencies that we usually have in our applications. Usually you would have this in a database, and that will run on a database server. So how do we actually handle that in acceptance testing? If we go back to the hooks class, let me just close all this stuff. It's possible to, as a part of the startup, we can spin up containers. Here I'm using the Doctors Fluent Docker, Fluent MPI, and it's a very, very easy way to spin up a container as a part of the test being run. It has a Fluent API. Now I'm just pulling a Postgres API. But let's just, Postgres image and spinning it up. And let's put a breakpoint here, and let's just run this as debug. And let's see what happens. So now we're spinning up our web application factory, and hit the breakpoint. Let's go to Docker. So you can see here that the container has already been started. It's actually exited. I'm not sure why, but as you can see, it's very, very easy to spin up a container as a part of the build pipeline. And if we go to the web application to test, this is also easy to override the different settings that you would have in the app settings in the web API, for instance. So that would locally, when you're testing, you maybe have a container running where you have your database there, but that connection string will not be valid as a part of the test. So we have to override that, and that's pretty easy to do as a part of the configure web host. We can run the builder.configure test services, and we can say, okay, in the connection strings dot my connection string, I want to use this connection string instead. So this way you could actually spin up a container with your database as a part of the test. Tell Specflow, hey, I want to use this connection string instead, point to the test container, and that will integrate to that instead of your other containers. That means that when you run this in your build pipeline, you don't have anything, you don't need anything to be set up beforehand. It will spin up the container as needed, and it will be shut down as a part of the after test run. As you can see here, I have just this container disposed, and it will turn down the container, turn it off, and discard it. All right, so this is my very, very short introduction to what you do when you do acceptance testing, how to use a Gherkin, and how to use Specflow together with Gherkin to provide acceptance testing in an automated fashion. I hope you enjoyed this, and don't hesitate to reach out to me if you want some a chat about this. I'll always be open for answers. For questions and answers.